Today we are going to study an important statistical concept called correlation. Correlation is a statistical technique used to measure and describe the strength and direction of the relationship between two or more variables. It helps researchers determine whether changes in one variable are associated with changes in another variable. Correlation does not imply that one variable causes the other to change. Instead, it only indicates the degree to which the variables move together. Correlation is one of the most important concepts in statistics, data science, economics, business analytics, engineering, medicine, scientific, and social sciences because it helps identify patterns, trends, and associations within data. By analyzing correlation, researchers can understand relationships among variables, make predictions, improve decision making, and develop mathematical models for solving real-world problems. For example, the relationship between study hours and examination marks, rainfall and crop production, advertising expenditure and sales revenue, or temperature and electricity consumption can all be analyzed using correlation techniques. Understanding these relationships enables organizations and researchers to identify influential factors and optimize their decisions. The relationship between variables may be positive, negative, or zero. A positive correlation occurs when both variables move in the same direction. As one variable increases, the other also increases, and as one decreases, the other decreases. For example, students who spend more time studying generally obtain higher examination scores, and companies that increase advertising expenditure often experience higher sales revenue. In these situations, both variables change together in the same direction. A negative correlation occurs when the variables move in opposite directions. As one variable increases, the other decreases. For example, as the speed of a vehicle increases, the time required to travel a fixed distance decreases. Similarly, increasing exercise levels may reduce body fat percentage, demonstrating an inverse relationship between the variables. A zero or no correlation indicates that changes in one variable have no consistent relationship with changes in another variable. For example, a person's shoe size generally has no meaningful relationship with their intelligence or examination performance. The strength of a correlation is measured using the correlation coefficient, commonly represented by the symbol R. The value of the correlation coefficient ranges from -1 to +1. A value of +1 represents a perfect positive correlation, meaning both variables increase or decrease together in exactly the same proportion. A value of 1 represents a perfect negative correlation, indicating that one variable increases exactly as the other decreases. A value of 0 indicates no linear relationship between the variables. Correlation values close to +1 or -1 indicate a strong relationship, while values close to 0 indicate a weak relationship. Generally, values between 0.70 and 1.00 or 0.70 and 1.00 are considered strong. Values between 0.40 and 0.69 or 0.40 and 0.40 and indicate moderate correlation, and values below 0.40 represent. The sign of the coefficient indicates the direction of the relationship, whereas the magnitude indicates its strength. One of the most widely used methods for calculating correlation is the Pearson correlation coefficient, which measures the strength and direction of the linear relationship between two quantitative variables. Pearson's correlation assumes that both variables are measured on interval or ratio scales and that the relationship is approximately linear. The coefficient is calculated by comparing the covariance of the variables with the product of their standard deviations. When the variables increase together consistently, the coefficient approaches +1, whereas consistent movement in opposite directions produces values close to 1. If no linear relationship exists, the coefficient approaches 0. Alternative methods such as Spearman's rank correlation or Kendall's tau correlation may be used. A scatter plot is one of the most effective graphical methods for visualizing correlation. In a scatter plot, one variable is plotted along the horizontal axis and the other along the vertical axis, with each observation represented as a point. If the points rise from the lower left corner to the upper right corner, the variables exhibit a positive correlation. If the points descend from the upper left corner to the lower right corner, the variables exhibit a negative correlation. When the points are randomly scattered without any identifiable pattern, little or no correlation exists. Scatter plots help researchers identify trends, detect outliers, and determine whether a linear relationship is appropriate before calculating the correlation coefficient.